The circuit shown shows a thermistor connected in a circuit with two resistors, an ammeter and a battery, a VMF 15 volts and no internal resistance, okay? So when the thermistor is at a certain temperature, the current through the ammeter is 10 milliamps. What's the potential difference across the 540 ohm resistor? Alright? So let's think about what we could do here then. We're trying to find out V. And we know the current is 10 times 10 to the minus 3 amps. So we know here that V is IR, which equals 10 times 10 to the minus 3 times 540. So the voltage across there must be 10 times 10 to the minus 3 times 540, which equals 5.4 volts. So what's the potential difference across the 1200 ohm resistor? Well, we know if it's 15 volts EMF and we take away 5.4, it must be 9.6 volts. So what must be the resistance of the parallel combination of the resistor? So this here must have a resistance R equal to V over I. V equals 9.6 divided by 10 times 10 to the minus 3, which equals 960 ohms. And then it says, well, what's the resistance of the thermistor then? Now then, we know that our equation 1 over RT equals 1 over R1 plus 1 over R2. Now, in this case, R1 is our 1200 ohm resistor, R2 is our unknown thermistor, and R is 960. So we could say 1 over 960 equals 1 over 1200 plus 1 over X. So 1 over 960 minus 1 over 1200 equals 1 over X. So if we use our calculator, one over X equals 1 over 4,800. So X must equal 4,800 ohms. Then it says the temperature of the thermistor is increased so that its resistance decreases. State and explain what's happened to the potential difference across the 1200 ohm resistor. Now let's think about this. If the resistance decreases, if the resistance of this thermistor goes down, then the resistance of this whole section goes down. Now if the resistance goes down, then the potential difference will also go down. Because it's got a smaller percentage of the total resistance, and therefore V out, if you like, think of it in the potential divider, it will have a smaller potential difference across it because it's got a smaller resistor. So here you would have to say, if this goes down, the resistance of the parallel resistance goes down, and therefore it's got a smaller percentage of the overall resistance, so a smaller voltage across it. Okay, and you need to write that there for your 3 marks.